Yes, we are live. What are we discussing today?
Eric found some NASA software thing that I thought looked like fun to review. The Rosa AI agent.
I didn't look into it. I found it just a few hours ago. It was shared on Warcast. And it's interesting because there is some signal here that NASA is still betting somehow on ROS, basically. Okay, because recently we had the news that the Viper mission, which was a lunar rover using ROS, was or space ROS maybe, was abandoned. Okay, and several people in the ROS community were wondering what it could mean. Okay, and now this. Okay, so it's interesting. Okay. Thank you.
Can we look at the README? Those or
This
ROS.
is just LLM interface to ROS, right?
Which one do they use? Llama 3 or something? No,
LangChain framework.
I don't know that one. What is that?
It's sort of like the ROS of LLMs, to be honest, of like
Okay.
completely over-engineered way to solve a actually pretty simple problem.
So maybe LangChain is what we should look at.
Yeah, it's worth looking at if you have never seen before, just because it does encapsulate some very common patterns, but pretty much anyone who builds anything real eventually ends up dumping it, which I guess is different than ROS, because for whatever reason, people seem to really like ROS.
Only game in town?
Well, you need some sort of glue. Well, it's not the only game in town. There are other middlewares. People just don't know them, so they just start with ROS and keep using it. There's something called yet another robotics platform called YaRG. I think it's made for real-time middleware work. There's a university in Switzerland that uses it for humanoid robots a lot. And then some labs build their own. So the lab in Helsinki I was in used to have its own middleware. So it's not that uncommon to not use ROS.
So
Speaking of middleware, I could also demo my stack again. I just got everything working on this rover just now. And it's been a little while since I had a working robot.
All right, that sounds like a plan.
All right, cool. So let me so if you recall, I was still kind of doing the whole base my rover on constructs, the plastic toys from the 80s sort of restriction on my mechanical design. However, I got kind of stuck when I put this thing together. So I had my board that I made, which acts as the motor controller for an ESP32, worked, and then I built a little rover that fit that. And then I had mechanically it just didn't work well because I was relying on the wheels from the kit that are just like they're too loose and they stick out too far on the motor. So this is the shaft that like sits on the very end of these teeny tiny N20 motors, I think, and just like the leverage of how far these stick out, like they're plastic, so they would bend a little bit. They don't quite fit tight enough because they're just press fit on there. And so they were just falling off every time I tried to actually use anything. I was like, any development that I do on this rover is just like hindered by the fact that no matter what I do, a wheel will fall off and I can't really do much of anything. So then I was like, okay, I got to design a new wheel. And then that blocked me for like 6 weeks or something. Like I don't know. I just couldn't get back into modeling and printing something and even having an idea of what the hell I was going to do. Because I also went down this little bit of a route of like, it's a very rigid frame, and you kind of like a little bit of give, like a little bit of a suspension. And so I was experimenting with printing TPU, and I completely broke the board that you print on, the print plate on my 3D printer, because TPU is really, really sticky, and if you don't take special care, you will rip the coating off when you try to remove the TPU off the build plate.
Wow.
And so I like ruined a build plate, and just like this TPU thing is a disaster.
Do you have a Prusa printer?
It's a Prusa, yeah.
So it has some plastic overlay or layer over the actual build plate, right?
Yeah, it makes it. It gives it, I guess, just the right amount of stickiness / whatever for PLA. But if you start printing TPU, you're supposed to either use. I heard some people talking about printing on like cellophane wrapper, putting that over the build plate, which seems kind of crazy. But I guess also putting glue somehow makes it work better, or hairspray makes it work better. Just not raw build plate. That's also messy and a pain. So I haven't got back to the TPU thing, but I did buy a new build plate. That's
I
my
didn't
TPU.
Yeah, when I tried TPU, it didn't have any sticking problems, but it was very hairy. Like it came out with hairy stuff, and I think I figured it out by slowing it down enough. So I did figure out how to print, but yeah, I didn't have the stickiness problem. So
It
yeah,
probably also depends too on like the amount of surface contact. Because I did print successfully like 1 or 2 parts, but then this other thing that I built, it which just wouldn't come off and stripped it off. So it's a little iffy. So I think it just needs just a little something else to get in the way of the stickiness. But so anyway, that also sent me down the route of like, well, one of the cool things that I've seen in 3D printing is how like you can have things be slightly flexible even though they're in PLA. And PLA gets brittle, right? But like you can kind of make things that have flexibility to it if you like print thinly. And so I got this idea of printing a wheel that might, in PLA, that would still have a little bit of give to it, more so than if it was just solid. And so I started designing stuff, and this got really ridiculous, and I was like, this is never going to work.
So you mean by playing on the infill and stuff, such kind of parameters?
The infill, but also like, I mean, if you can print something really long and thin that has just a little bit, it'll have some flex to it. Right? Okay. I think I had I printed a carabiner that I had gotten off of like Thingiverse or something, and it's got this kind of like interesting mechanical aspect to it. Like there's no springs, there's no truly mechanical like metal parts in it. It's just like by virtue of being just a little bit flexible, it has this it's kind of a strange mechanical flex. I forget what the term is.
There's a whole it's called compliant mechanisms. There's
compliant mechanisms. Yeah.
So if you design the right geometry with gaps and like spring like shapes, you can make stiff materials behave like soft materials. So yeah, the only tricks I've used with PLA like that is like to build notches or gaps into like what would otherwise be solid, and that makes it flex well. But yeah. A friend of mine did a PhD in compliant mechanisms. So
and maybe we talked about this before, and that's what got it stuck in my head. And I was just like, what a cool idea that it's probably kind of hard to do, not 3D printing, but with 3D printing, it seems like that should be possible. Mm-hmm. So I designed this wheel, and I'm going to share it. It seems absurd. Let's see.
Well, what about the wheels of curiosity and maybe also perseverance? They are really they are entirely metallic and hard. Okay, yet the rover is also very heavy, and so they were designed to be able to work on Mars.
Yeah, I think that is also the key of the rocker bogie suspension, in that it's a springless and flexless way to get, you know, the weight distributed as needed.
Okay.
Whereas if you've got 4 wheels and they're fixed to the frame, you need like a car, you need like a suspension of some kind.
Mhm.
Some sort of wheel travel that's got to be independent of the rest of the frame.
So basically, you took one of these rotating leg things and you stacked a few of them. So now you have nearly circular circumference.
Yeah, exactly. So I actually constructed this by like drawing a circle around it. That was going to be, this is what my frame is going to be, and then started building these spines and then duplicated it in 3 rows to kind of give it. I didn't actually think this was going to work. And in fact, the very first one I printed was it was thinner. I went back and adjusted it, but the very first one I printed looked like this, and they're so thin, they're like hairs practically, and I was like, well, there's no way that's going to work. But then I was like, well, I got one more try. I can probably make these a little bit bigger and give it another go. Also, I didn't think it would come off. I'd be able to print it because, like, think of the overhang situation on this. Like, it's not really optimized for 3D printing. That's like a whole other game. So I didn't think it was going to work, but I just like printed it with supports, and it prints it sort of as this solid wheel, but it's filled in with all these like, you know, temporary structures that it actually popped out kind of fine, and the whole thing printed in 50 minutes, I think. But it was a mess when it came out, and you got to, you know, clean off all the pieces, but it came off easier than I thought it would.
I have 2 questions to you. One, can you turn these legs into loops? And the other one, why do you think they have to lie on the plane?
My theory was that if they're not flexing, it should still operate like a regular wheel in that it's round.
No, but you can make complete each leg into a loop. That's my question.
It wouldn't flex then. The whole point is that the circle is interrupted. That's what allows it to flex easily.
Depends on the material. If you make it thinner, it would be flexible. Also, if you had, you know, closed the loop. I'm worried about stuff getting caught. You know.
Yeah, I think that's a very fair point. And I ended up, I think I cut the end of this loop. Actually, the very first. Let me show you the sketch. So when I was constructing the curve, I ended up cutting this shorter than I originally did because it started to interfere with the neighboring piece, I think.
Mm-hmm.
So it was unclear, but I wanted it to be up far enough to try to avoid as much as possible it catching on something, because I've got him going in both directions, and you may want to go forward or backwards. So there's always a possibility of catching. I could imagine wanting slightly more clearance, but I didn't think it was going to work at all anyway. So I was sort of if this was my problem, if it catching on things,
no, it's fine. And the second question had to do with being in a plane. You have all of the legs, you know, in the same plane. You have 4 levels. Why not? I mean, not why not. What do you think about having them at an angle?
Oh. You mean like not...
You know, like 10 degrees, you know, not...
So they're kind of like splayed out?
Maybe more like, it would look more like a blade. In other words, when you look at it head on, they would look like they're at an angle, but they still fit inside this cylindrical shape of the wheel.
Oh, yeah.
Omnidirectional wheels kind of have that skew geometry. The video I posted, I've showed it before. This is from like an old professor of mine. It actually has legs similar to your wheel rat, except where you have like a dozen of these, it's just a single circular hoop per leg. Can you play that video quickly? You'll kind of see how it works.
Yeah.
Right, but that's actually legs. Here it's a wheel.
Yeah.
Because these legs also jump and do all this other stuff.
Yeah. But the principle is the same. This flexes because of the same compliance principle. It's
Yeah.
not a complete circle, so the I think they call it the hoop stress is lower. Yeah, so Rhett's wheel would have a smoother motion than this, and I think yeah, you don't need as many spokes as you have, Rhett. I think you could have as few as like 3, and it would give you roughly what you need. But yeah, the more you have, the lower the load on each, I guess. But yeah,
Yeah,
this
and
the
also
concept basically works.
you have to really dial in exactly what they're going to support. And I was kind of like, well, maybe some of these are going to break, and maybe an assembly of them might work out better. But
Yeah, but
certainly this
also
shape would
look,
be a hell of a lot easier to print than what I did.
look, Vex is always moving the legs in a way that it doesn't get caught in anything. Okay, while Vex wheel, whichever
Okay.
direction you go, if you're
These
walking
move
on
left.
grass, you
Or
have the
they-
lift.
I think they're offset.
Yeah,
Or
but they're
middle
always
ones.
moving backwards, you know? They're moving away from picking something up with a leading edge.
But let's look at your wheel. You said you managed to print it, right?
Yeah. So
Show
let's pull this up. It'll focus on
cool.
there.
Those
Yeah.
are really
No,
slim. Nice.
Yeah, they're pretty
And you,
slim.
like,
They've
there
got
we go.
pretty good rigidity. Why can't I get that to focus? Do I have to get out of the way?
No, it's clear. It's not.
There we go. Okay.
You know
So,
what
yeah.
this reminds me of? This reminds me of the lunar rover's wheels because the moon has no atmosphere. They use that. It looks like chain mail, basically. Do you remember?
Yeah.
It looks like the lunar rover wheels. Yeah, that's pretty cool.
Yeah, it actually works, and I'm gonna see if I can. I thought maybe I could broadcast or change my camera to my phone. Is that a thing?
And those are entirely PLA, right?
Those are entirely PLA.
Yes, you can change the camera to your phone if you have attached it.
I think I did have it attached once, but
How do you attach a phone to your Zoom session?
Well,
it's like
I use an app.
operating system level.
I use an app called. So right now I'm using my phone as my webcam. So I use an app called iRuin. So you have the app on your phone, and then there is a. I think it works on Mac too, but then you use an app called iRuin on your Windows or Mac machine, and then you connect to the same Wi-Fi.
I used to have an app for that, but it was on my other laptop, and I don't have. But it's supposed to be built into the.
So I
don't know.
iRIUN iRuin.
I found it.
Well, anyway, I will. I think I can maybe do this still.
I want to say something about the getting caught problem. When you have an automobile, you're driving, 70 miles an hour on the road. If your wheel got caught on something, it'd be the end of you. But all rovers are moving slowly, and they also have a brain. So if suddenly they get caught, they can stop and spin the wheel in the other direction or whatever's needed. So it's not necessarily, a problem.
Is this going to focus? Come on now.
You can touch the phone screen maybe once.
It's not on my phone. It's on my webcam. That's
Okay.
Oh wait. Oh. Oh wait. You know what I need to do? I can turn off. There we go. There we go. Okay. So let me also share my screen because you can get the. Oh, that's this one. Can you pull up my screen too? Cool.
Yeah.
All right. So I don't remember if you guys remember this or not. But this is my ground.
I think your audio
Red,
died.
you disappeared.
Red's audio
No.
died.
I can sort of hear, but very faintly.
I think the mic has switched.
Briefly. How about now?
Yes, now it's better.
No?
Good.
Okay. Yeah, so anyway, this is my YaRG ground data system application that I've used to control this thing. I think it's working based on the second since boot is being updated, so that's a good sign. And it's showing me what the current Wi-Fi strength is. I think this will not run off the desk if it works. Yeah.
Cool.
Wow. Can you show us a side view so we can see only the wheel? I mean, because here it's black on black, it's hard to see.
Oh, yeah, sure.
Yeah.
Let me see if I can put. There we go.
Yeah, I'd like to see the bottom of the wheel.
Oh.
No, it's fine. I see it now.
Oh, okay. There we go. Yeah. But I wasn't sure if it would be able to turn or not. That was the other real question here. But it kind of does.
Yeah. What happens if you put a little piece of Lego for it to bump onto? Can we see that, or maybe a pencil?
Yeah. Let's see. Find something good here. That might be too big. Legos. I need to have Legos. Only these little tiny pieces. I think that's the front. All right. Moment of truth.
Wow.
Oh, look at that.
Is it too much to ask that you put on the old wheel so we can compare it?
Yeah, that's good. That's a good point. So these are still just like press fit on. Which I don't love, but they, for whatever reason, these printed better.
So the idea of it getting caught in stuff could be a feature if the job is in fact to catch up stuff, like harvest some stuff. Like you could take those things into blades and they can be
wow.
be a harvester machine.
Why not make every other wheel a blade and then you use it to run over cockroaches,
And where is the fourth wheel? Did my kid steal it?
Is it the same size as these? So you can make, mix and match.
Yeah, that's true. It should be here though. What did I do? All right, I'll just put one back on.
It's the same diameter, the wheel?
They are pretty close.
Okay. Oh yeah, I can see the sagging from the.
Yeah, it just doesn't quite have the.
Good. Yeah.
And they just come off super easy. Oh, see, yeah. Therein lies the problem. And I guess these could have like these shafts. Maybe I could get them to be slightly less. Put the tolerances slightly down, but like, I think there's just so much sideways force when it moves, that it makes it kind of hard no matter what.
All right. So now we are comparing.
Yeah. And I mean, it's gonna it works.
No,
It's
you
pretty,
have to go over a piece of Lego. I mean,
yeah, there we go.
yeah.
I'm rooting for it to fall off.
Yeah, I know.
Yeah, but that wouldn't be a fair comparison.
Yeah.
It
That is a
actually is
complete-
almost like it's just barely kind of hanging on.
No, but it's a completely different dynamic when it goes over the
Yeah.
Lego pieces. So you want to just replace that wheel, the one that's looking at us, with a, I don't know, spline wheel?
Maybe we can flip this around and
Yeah, okay.
do it backwards.
Much nicer, I have to say. I think the movement of your spline, I'll call it a spline wheel, is much nicer.
Yeah. This is cool. I think if you made it a little bigger, it could go over fairly decent sized obstacles.
Yeah, I'm kind of inspired to make them bigger. The only consideration I was trying to figure out is if, like, I mean, I'm limited in how big I can make them until they start hitting each other.
Oh, yeah.
But this is PLA, right?
It's PLA.
Okay.
Oh, that's where the robot I showed in the video, that gives you an opportunity, right? If you make them not a full circle, the envelope of these little leggy things, if they're like staggered, you can kind of like get them larger but still closer to each other. You just have to make them more like legs, basically, like two half moons out of phase.
Well, if they had an offset geometry where, like, this one was out and this one was in,
Yeah.
then they could slip between each other. Although this also, the overall balance of this thing is going to get maybe a little wacky if the wheels get too big. I don't know.
I mean, there's a
Because I could also make it longer, but like loses.
It's not worth
integrity.
optimizing on this chassis, but as a proof of concept, it's great. It's worth thinking of this wheel for the Yakuza, for example, like putting it on the tumbler.
Yeah.
I gotta say, I really like this idea.
Yeah, and I also kind of want to do like I wonder how many tens or hundreds of feet of distance I can travel on these and have them go before they break. Just how brittle is PLA? And does it matter if one or two of them just fall off?
I think you have a different problem. It's a problem of wear. In other words, if you lose, a few tens of microns to the wear, the whole handling changes and makes it more likely to break. But the handling will change.
Yeah, interesting.
Remind me again how the tail scale servery thing works.
Yeah, let me walk through that. So this is running on our YaRG Robotics Garage GitHub account backed tailnet thing. So I have you can see this, right? Yeah. So I've got two tailnets I have access to on mine. I can connect to my personal one or the YaRG Robotics Garage one. And so anyone that's on the YaRG Robotics Garage can actually hit this page. But how the rover connects to it is slightly awkward because I could never get HTTPS to work. So what I had to do,
You mean on the ESP32, right?
correct.
They,
So I have and yes, that's my Wi-Fi password in there. I don't care. Anyone who watches YouTube can feel free to connect to my Wi-Fi. This has the GDS URL. This is my local network IP address. And then what I ended up doing was running a reverse proxy web server, which is kind of terrible, but that basically proxies from my my computer, my laptop, over the Tailscale network to where this YaRG GDS VM is running. So that's
what is reverse proxy?
So reverse proxy means that there's a web server running on port 3099 that if anybody connects to it, it will actually rewrite all the HTTP headers and everything and connect to this other web server and make that web server think that they're talking directly to the rover when in fact they're talking to my laptop. So you can see this line right here, it's rewriting a host header because the host header in the HTTP request is what actually got connected here. So it actually thinks it's connected to a web IP address. So this throws that in there so that the web app thinks that it's connected to a specific name.
So what is a caddy file?
So caddy is a web server like Nginx or Apache, but it's modern-ish.
Okay.
Kind of the new hotness. It's got some other cool features, like it is. I'm not using it in this particular example, but you can set up caddy to automatically generate your certificates for HTTPS stuff, or if you're running it over, it's Tailscale aware also, so it can use the Tailscale stuff that it knows that it's what it's connected to. It can pull that correct certificate. So I'm also running caddy on the machine that's running this YaRG GDS thing, but configured differently.
So this is kind of like an orthogonal way to set up control over networks compared to the Farcaster ngrok thing that Anuraj did, right? This is you have to create a trusted group of people who are all in the tailnet, and then they can control your rover. You're not tunneling through to a public service like Farcaster.
Yeah, fundamentally the difference is that I'm using Tailscale instead of ngrok, and so only people who are on the tailnet can access it, as opposed to anyone who knows the ngrok address.
Can you combine the two strategies so that you have a inner permission level that works on Tailscale for a trusted group, but maybe an outer ring that works through ngrok, and maybe they can do simple secure commands, but insider people can, I don't know, fire a gun or something?
I think the server, instead of the server on ngrok, we could have the server on Tailscale, right?
Yeah.
The Farcaster server, which I was running, basically exposing via the ngrok IP or the URL. It could be I have a DigitalOcean server, and then that could be put on a tailnet. So you have a kind of an external URL, but then it only connects through the tailnet to the rovers.
There is an alternate way to configure this that I tried. You can see it over here. So I was logged into the YaRG GDS machine, and there's this thing called funnel. That's kind of the equivalent to ngrok behavior, where Tailscale will actually handle public access to this host and then forward it to the actual host. This doesn't work in this situation, what I found out, because they only support proxying TLS, HTTPS connections, really, and there's not really a way to get around to fool
anything into just talking HTTP, and since the ESP32, I couldn't get it to speak HTTPS, so that didn't quite work. And ngrok, I guess, doesn't have any restriction on, like, you can just run a.
Yeah, that was going to be.
Well, you have to force it to use HTTP. By default, it runs HTTPS.
Yeah. Yeah.
I don't get how permissions and stuff are inherited on Tailscale. So if there is one machine on the tailnet that's exposed to the public web via like a public IP, and a request is coming in from some random external client, how do you know that it's trying to do a safe thing to the rover? And
yeah, so it would not be safe at all. Like, this funnel is like, I'm just going to expose this thing to the outside world now. You better be fine with that. And
maybe it can be token gated with.
Yeah, I would have to have built authentication directly into the app, which I did not. And in fact, what I did instead, which was more fun for me, was I do have authentication. I just added this actually, where it says I'm signed in as RETG, but that's actually because it knows what IP address I'm coming from, and it looks that up in Tailscale and authenticates that way. So it just knows that it's my laptop.
Okay, so I'm still not quite understanding how the proxying works to the outside world. So the rover sees all requests just coming from your laptop, right? Even if they're like being relayed from somewhere else. So it cannot actually.
Oh, yeah. So the other big difference between this setup and what Anuraj is doing is that the communication is going the other direction, because I'm putting the IP address of my server into the rover, and it's calling out to try to find a server to talk to and pulling commands down, as opposed to offering a web server that receives commands as they come in.
It feels
and
like
so it could connect to a server anywhere.
Yeah.
So it would be nice to actually have that. And since there's not really a reasonable way to try to run Tailscale like on the rover itself, that works fine on my Raspberry Pi based rovers. That's what I did for my other ones. And so those are actually much more straightforward, that they can just be on the tailnet with everybody else. But the ESP32, a little more limited. So really all I can count on is I've got an IP address on Wi-Fi, and then it has to try to find a way to contact a server somewhere. So that server could be anywhere, but it has to be either public or on my actual local network. And so the way that I've solved it was having it connect to an IP address on my local network and then proxying that across to the tailnet, if that makes any sense. So what it could be, I could expose an API endpoint for the server that is actually publicly accessible and has some other authentication scheme, like a token or something that's got to be passed in. And then that can just be public, and if you built your application secure enough, I guess maybe it's safe. But
I'm actually trying to think in terms of like having the best of both worlds. It sounds like Tailscale is the solution if you want to have like a trusted group that can do a lot, and something like Farcaster would be like a way to expose like a lower trust level of agency, right? So
yeah,
the rover should be able to distinguish that this particular command is coming from a trusted computer within the tailnet, and therefore it can do way more, or this command is being somehow relayed from the wild west out there, and therefore I'm going to like just not do certain things. So where is that logic implemented? Should it be at the edge between the tailnet and the outer world? Should it be on the rover itself? Should it be on some machine in the middle? Like, where is that trust logically fitting?
The way this YaRG GDS application is architected is to sort of mimic how I was thinking that the cell card that I bought as an experiment and then never actually used. They have this cloud service that they offer. So like all the communication that you have with your over the cell network is actually to their cloud service. And so it communicates in a series of notes, and you put notes in a queue and on your device, and they eventually get updated to the cloud, and you download notes from the cloud, and then you can access them on your rover. And so this kind of works the same way in that it's like a clearinghouse for communication between users and the rover. So I would say that that application, that information could be figured out inside of this application. You could somehow expose and just have to have some authentication system that there's tokens that determine it, or maybe there's some special URL that you design that you give to Farcaster or whatever, that this is the one URL that it's allowed to access to, and everything else has to be authenticated, but this is like a publicly accessed one. And then since I've actually got this authentication system in here, I could set it up to where actually only logged in people can visit any of these pages. You have to be signed in as somebody, which means you are on the tailnet.
So one reason this is on my mind is I'm following the news in Russia and Ukraine, and they're using off-the-shelf commercial drones and hacking into each other's drones. I think when Ukraine just invaded Russia, they took over a bunch of traffic cameras that were on the street lights and used that to track the Russian army. So I think this technology is actually going there, and this is a more serious functional capability than I thought. I think this is now a load-bearing feature of any rovery thing that's built, right? There should be inner trust, outer trust, and security against being hacked. You can't secure against stuff like being jammed, but you can. I think you can do better than what's going on in Ukraine right now, because that's.
Is there anything publicly known about what are these communication mechanisms that those drone systems use? What?
I think they're using just the regular FPV drones that you can buy commercially. At least the Ukrainians are. There's also the military grade other drones, but they're basically just using regular commercial unmodified drones.
VHF video signals and the whole.
Yeah. And so they're prone to jamming, interference, being hacked, all that stuff. I'm sure they've done some mods for security, but as far as I can tell, it's commercial, yeah.
Interesting.
But yeah, I mean, this would kind of be interesting, especially if you're thinking rover applications mainly on Earth, in at least the near future. You kind of want, suppose we end up building a few interesting rovers and you have a mobile hotspot in some public park and you want to play with it at a higher authority level. But if somebody around wants to play with it, you can hand them the remote with lower authority level. I think that this is I feel like it's not an optional feature anymore. This is kind of has to be part of the stack. But yeah, it would be interesting to see Farcaster plus Tailscale all together. But this is pretty cool. New wheels.
Yeah, new wheels. It's nice to have a rover that can move.
So it's using the board. It's using the board you are using, PCB design you are using, right? Design.
Yes.
Yes. Okay.
Yeah, I forgot. Yeah, you did make your own ESP32 board, right? What was that? What did you add to it?
Yeah, so it was just essentially a breakout to connect to 2 motor control chips.
Oh, okay.
I kind of forgot actually that the big thing I was trying to do was that I can actually control the speed of all 4 of these wheels independently. Unlike even the Mars, the rover thing where we got kit is there's only really 2 channels. You can turn the left. The wheels on the left can go forward or backwards, and the wheels on the right can go forward or backwards. But I was kind of interested to see what do you do if you legitimately have 4-wheel drive? So I put 2 chips together and that lets me do 4 channels, as opposed to like the off-the-shelf one, which is in this other rover, which is the Raspberry Pi one.
Okay.
You probably can't see that, but that's the off-the-shelf like motor control driver that I bought, but it only does 2 wheels.
So, what about the body? Do you think the body should be rigid beams like what you did, or maybe you also have some idea for what the body can be made out of?
Yeah, when I was doing my TPU experiments, actually, let me see if I can find one of these parts that I printed, because it's kind of interesting. Didn't quite work, but oh, that's right. I had another wheel experiment I didn't mention. I never did finish this one, but here's this big wheel I built. It has little TPU feet on it. I was like, well, let's see what kind of mechanism that gives me. But this turned out to be really hard to print also. I was really struggling to get it to, can't quite see, but on the surface, it's like real like rough and stringy, like it would hit stuff on the edge. And so it took forever to print. So it would go for like 2 hours and then it would fail because it keeps creating some little ridge that the nozzle runs into, which is super frustrating. So I only ended up printing one of these, and then printing these little TPU things proved to be problematic once I learned that I could break my print bed. So I kind of abandoned that, and then I'm not sure if I really believe that's going to work super well anyway. But that was really built for the for this one, which had kind of larger wheels on it. But then I also built, because I was like, well, maybe the frame itself should be more like, the suspension should be more like built into that. And so I ended up making these little guys, which are essentially the same shape as the little teeny tiny struts. And so they're basically a flexible version of the teeny tiny struts. And so when you can see where the wheels and motors connect, they're just separated by these short ones. And so the idea was, I could put these flexy ones in here.
Right.
Right. And so now I've got not so rigid of a frame. But I think the more of those that I added, or actually the other way I was trying to do it was like, make it so that on this other rover, I could replace like these ones with the flexible part, and then maybe the wheel could travel independently if I got them all kind of offset with these slightly flexible ones. But that made the wheel behavior that much worse. Like when any of these, like when the wheels can flex at all, it just makes it terrible because they want to rip itself apart. This construct system is just not really rigid enough in the parts you want it to be rigid to allow flexibility in parts that you might like to have flexibility. So I don't know. So I think that was where I kind of went down the route of like, well, let's just experiment with the wheels instead and solve 2 problems with one design.
Yeah, I think if you wanted to use a modular design system for the mechanics, Technic probably is the most sophisticated one. And I've seen some YouTube videos that are pretty solid, done with just Technic parts. But yeah, in general, I think these building blocky things are good for like prototyping and like quickly checking out an idea. But I wonder if you wanted to do proper modular rovers, you'd kind of have to design a set of building blocks for rovers with like, not just use techniques and things. But I saw in Discord you posted a comment saying ESP, what is it? Yeah, ESP32 just seems like table stakes. What did you mean by that?
So that was in response to your
the Uno on these.
pointing out that it's like that rover kit is just an Arduino Uno and a shield on it, and it just sort of seems absurd to me that, like, now that I've seen just how much more powerful an ESP32 base system is, and like,
Is there a Uno form factor ESP32 that we can just drop and replace pin-to-pin equivalent? Maybe we can like upgrade the.
I don't think I've seen one, even because I think the Uno is, because it's using the what are those called? The other chipset, and they run at 5 volts. All the electronics run at 5 volts.
Okay, so the same problem Anurag had.
That old problem.
Okay.
For the brains, I found. There should be something. Yeah, I think what Eric has.
This is an old board which is called the ESP1, like Uno. Okay, but it's a room on it here.
Okay.
Is that the regular Arduino footprint?
I'm not completely sure, and I don't have any more Arduino Uno here. Okay, but it might be. It looks like the same power supply. Okay, and I remember these ones on the Uno. Okay, but I'm not so sure. Okay, but it looks a bit wider. A bit wider here.
Yeah, it looks close though.
You could have a plug-in in between.
The other one is the room.
Yeah,
it's an older model. Huh?
Yeah, it's the same.
So ESP32 here, you're saying it's table stakes because of like the higher processor and memory, right? Nothing else. Okay.
Higher processor, memory, and like Wi-Fi.
Right, but this one does a breakout board for the Wi-Fi, right? The Uno based.
Does it have Wi-Fi on there, or is it a Bluetooth?
I think
it does have a ESP32 cam.
Yeah, I think it is connected to Wi-Fi, but I don't know. I haven't yet gotten to that stage in my build yet.
But it's not the main processor, I guess. It's just used the cam.
Oh,
actually, I had found so this Kickstarter started yesterday, and I had been thinking of designing the hat in the form of a RPi hat. So if we basically use this like board as the ESP32 board, then we can stack on top of hats on top of it, and we can basically also connect the RPi to this. So this already comes in the form of RPi form factor, and then you can stack on top of this. So I was planning to design a RPi motor control board or a motor control board in the form of a RPi hat, and then I could stack that on top of this. So I was thinking something like that. But this started yesterday, so the delivery is in November.
Wait.
But
so you would design a hat and stack it on top of this, on top of an RPi? What does this do?
We have to connect each of them together anyway.
Wait, I don't understand what this is doing.
So this is just
multiple
like ESP32 in RPi form factor.
Oh, this is ESP32 in RPi. Okay. What's the advantage there? RPis are more powerful, so there's not going to be a processing advantage in using an ESP.
You reduce the cables, basically.
Low power?
Microcontrol RPis don't do proper microcontroller, right? So maybe that's
no, but then you have to connect them anyway. So if you stack them, then you reduce the cabling. That's it.
Oh, so okay. So you want to use this as an RPi plus an ESP32 plus a hat for the RPi part.
What? Yeah, whatever.
Okay.
But they would have had to, like, is the circuitry set up to where you could like turn off the RPi from the ESP32?
Yeah, that I haven't checked. This Kickstarter started yesterday, so I'm just checking. But it has a lot of stuff on the board itself.
This seems awful esoteric to have raised $10,000 already.
I guess a lot of people are running into similar problems. Oh, but while we are on RPi, I just saw that thing about the new RPi Zero that has RISC-V cores. Did you guys see that?
Yeah, it's a quad core, but I don't think you can use it at the same time. So either you are using a RISC-V or you are using
Yeah.
ARM, something like that.
That's what I was getting at. So we can use that to experiment with RISC-V if that's still of interest.
What do you mean you can't use?
I think during boot you choose which processor you are going to use. At least that is what I read. So
Yeah.
during
Oh,
boot,
so it's
there
got
is something.
multiple actual. It's got two different architectures on the same board.
Yeah, so it has got 2 ARM cores and 2 RISC-V cores.
Oh wow.
In an ARPI 0 form factor, which is the ARPI 0 comparable in power to like a Nano or something, compute-wise?
No, ARPI 0 is basically ARM Cortex A series. So it's a Linux computer.
Okay, so it's like in terms of
And
processing power, is it much more powerful?
much
or-
more powerful. And then this ARPI, so the new ARPI Pico 2350 is a microcontroller.
Okay.
And ARPI 0 is a Linux class computer.
All right. Yeah. Looks like you've been productive, Rhett. So.
Well, that was over a couple months, I guess, of work. So
All right.
I feel slightly unblocked, and like I can make progress on things now. So that's good.
Cool. All right. Next week, I guess. Yeah, I still have to do the forecaster thing, and we'll see how far we are on the new rovers.
Yes.
Great.
Okay.
Cool. Talk to you
Right.
later.